Kia ora, Year 11 and 12. This is question 3 from this year's calculus exam, and it's the one about 2 points on the graph of a cubic where the tangent to the graph passes through the origin. And we're told that there are 2 of these points, and we have to figure out what their coordinates are and the equation of each tangent. So this question looks like it's really, really hard to get into. So you have to go back to it and read really carefully to get some clues. So the tangent to the graph goes through the origin. Well, what does that mean? Well, when we were back in year 9 and we learned about the equation of a straight line, we learned that we could write the equation of a straight line as y equals mx plus c. And the other way that you can write it is using this form. And if you're in my class, you know that I like both of them, but usually I stick with this one. And if the tangent to the graph goes through the origin, it simplifies that equation down to y equals mx. So we're going to use that. Then we're going to go back to the function and think about what a cubic looks like. So a cubic goes up, down, up, like that. And you can graph that on your graphics calculator if you want to. And we know that the gradient function, the first derivative, will give me the slope of the tangent anywhere on that curve. So what we're saying here is that there are 2 points where when we take that tangent line, it's going to hit the origin. And the ones that I've drawn obviously are not, right? But that can help us see how to get into the question. So we're looking for a point that's going to do that, and there are 2 of them. Let's start off by differentiating this and seeing if that gives us any ideas. So the gradient function anywhere on that curve is found by differentiating. And so we get 3x squared minus 6x minus 4. And that's the gradient for any x value. Now let's think about what happens if we've got a straight line that goes through the origin. So suppose that I've got this point out here, which is A. Let's join that up. Well, we know that we can write the gradient m as the change in y over the change in x. But the thing that makes this really straightforward here is that one of those points is the origin. So the change in y here goes from y, this coordinate up here, down to 0, and the change in x goes from x down to 0. So m is equal to y over x. So if we want to have the tangent line on my cubic going through the origin, what I have to have happen is that my gradient here, this gradient that I found using calculus, has got to equal this one, right? Otherwise, it won't go through the origin. It'll go through somewhere like up here or down here. So let's now look at y divided by x. Well, y is x cubed minus 3x squared minus 4x. So y over x, which is m, is going to be that divided by x. Sorry for the interruptions, guys. Got a visitor. So here's x squared minus 3x minus 4. So that's the change in y over the change in x, and that has to equal what came out of my gradient function. So if I equate those 2 things, I get 3x squared minus 6x minus 4 is equal to x squared minus 3x minus 4. Solving that equation, so that's a pretty easy quadratic, I get 2x squared minus 3x equals 0. And this is starting to look really cool now. So I've got x into 2x minus 3 is equal to 0. And look, I'm getting 2 points coming out. So x is equal to 0, or 2x equals 3, x is equal to 3 over 2. Right, now what we have to do though is to find the coordinates, and then we have to find the equation of the tangent. But we've done all of the hard thinking now. So to get the coordinates, we need to put it back into f of x. So f of 0 is equal to 0 minus 3 times 0 minus 4, which is 0. So the first point, we'll call it A, is going to be 0, 0. And f of 3 over 2 works out to be, let's see, what did I get? So I actually did switch that to a decimal. If you're in my class, you'll be laughing. because I never do that, but here we go. So we get that minus 4 times 1.5, big mess, and that gives me negative 9.375. I'm going to show you all of this in GeoGebra in a minute as well. So point B is 1.5 and negative 9.375. Now the very last thing that we have to do is to get the equation of the tangent for both of those points. So the easiest way to do that is to go back to my equation for m, right? And m was equal to x squared minus 3x minus 4. So when at point A, m works out to be 0 minus 0 minus 4. So my tangent line at A is y equals negative 4x. And when I do the same thing for point B, substituting in 1.5, m works out to be 1.5 squared minus 3 times 1.5 minus 4. And what does that give me? That gives me negative 6.25. So the tangent at B is y equals negative 6.25x. So please don't stop watching just yet, because I want to show you how it all fits together on the graph. I just want to talk a little bit about this question, because all of the skills in here are very much level 2 skills, but they're just put together in a way that really, really makes you think. And you've got to understand pretty clearly how the equation of a straight line works, right? So y equals mx plus c is, I think, the key to doing this question, or at least it's the key to doing it how I did it. I think there are probably some different ways you could go with it. And then thinking about what it means for the tangent to go through a point, right? So the big idea in here is that this m is the same no matter where on the tangent line we are, and we know how to find the gradient on the curve out here from the gradient function, right? So we know that if it's going to go through the origin in that point, that slope has got to be constant, and it's got to equal what comes out of my gradient function. So just before you hang up the YouTube, let's just have a look in GeoGebra at how it looks. So this is the picture of, let's see if I can get that in the frame. This is the picture of the cubic, and you can see straight away from looking one of those points, right? So this is drawn, no nice ruler here, guys, but there's the tangent going through the origin. It's harder to see the other one, but if you just take your ruler and wiggle it around, you'll see that it's going to be like here. We're not quite going to hit the origin, but it's somewhere down here. So then we put the two equations on once we're finished, and that's the equation, that's y equals negative 4x. And then the next one is this one here. So we've got the point 1.5, and you can see negative 9 point ... over here, and that one also goes through the origin. So there you go. You feel free to leave me some comments if you need to, and let me know if there are any other questions you'd like done. Thanks for watching.